So from the previous video, we just looked at how we can evaluate an integral of this form, right? Whereby you have your denominator consists of terms of trigonometric functions squared, right? So now let me just try an example whereby, let's say, just one example so that you can see how you can evaluate this integral. So if you're given an integral 1 over sine squared x plus 9 cos squared x dx, we are given this, evaluate this integral. So the first thing, remember, if we're saying you have sine squared and cos squared, you're going to use the substitution. So I used t, so t is equals to tan x, right? Which means dt is equals to sec squared x dx, and we know that dt is equals to sec is what? Sec is 1 plus tan squared x, right, dx. And since we are saying tan is equals to t, that means dt is equals to 1 plus t squared dx, right? So this is what we have. So instead of dx, we are going to have dx is equals to dt over 1 plus t squared, right? So okay, coming back to this one, remember we drew a right angle triangle and we said this is 1 plus t squared, this is t, this is 1, right, and this is x. So now you want to find sine and cos with respect to t. So we are going to have sine x is equals to what? Sine is its opposite over hypotenuse. Opposite over hypotenuse. Cos is what? Cos is adjacent over hypotenuse, right? From this triangle. So now, instead of sine x and cos x, we are going to substitute these two expressions. So now your integral is in a form of 1 over we had sine squared x, which is going to be t over 1 plus t squared, this is root, this is squared, right, and then plus 9 1 over root 1 plus t squared, and then what is your dx? What is your dx? Dx is from this expression, dx is what? Dx is dt over 1 plus t squared. So from here, if we simplify this, we are going to have the integral of 1 over t squared over 1 plus t squared, because if you evaluate the square with the root, is going to cancel, and then you're going to have 9 over 1 plus t squared. This is dt over 1 plus t squared, and then the denominator is going to be 1 plus t squared over t squared plus 9 times dt over 1 plus t squared. Same denominator, you combine the function, and the denominator of a denominator becomes the numerator. That's what I did here. And then this is going to divide, right? And then now you have the integral of dt over t squared plus 9 squared, which comes back to the same thing that I derived here. So you are going back to this format. Just as I said, you're going back to this format. Whenever you have a trigonometric functions, when they are squared at the denominator, you go back to this format. We know that this looks very like the same as dx over x squared plus a squared, which we know that is 1 over a tan inverse x over a plus c, right? So even we're going to do the same thing here. 9 squared, right, is equals to this. So the integral of dt over t squared plus 9 squared is going to be 1 over 9, right, because 9 is our a, tan inverse of t over 9, right, but plus c. but we know that t is equals to tan x, right? So this is 1/9 tan inverse of tan x/9 plus c. So this is the answer for this equation, for this problem. So if you evaluate this, we are going to get 1/9 tan inverse tan x/9 plus c. So this is how you apply the integration techniques. You just need to know the procedure, how to solve, evaluate integrals like this one. This is the simplest procedure. There is another one whereby from this point, you can try it whereby instead of using the triangle, you can just multiply both sides of this integral. You can multiply both sides of this integral. This is dx. You can multiply this with sec squared x, and also the denominator with sec squared x, and then you simplify, you work it out, and then you're still going to continue get the same thing as this one. So this is how you evaluate the integrals, the integral techniques. So now with the next video, just going to look at other integration techniques and also look at the reduction formula.